let us look at this problem. So, there is a triangle ABC, and inside for this triangle there is a incircle whose center is I and its radius is small r. Incircle center is I, radius is small r, and it has a circumcircle whose circumcenter is S and the radius is capital R, and again the incircle and the circumcircle are touching another circle, So, I mean this circle touches BC at F and the circumcircle at G. So, it is touching the incircle externally and the circumcircle internally. So, the radius of this circle is r dash and the center is O. What we want is a relation between r in radius, circumradius and this circle radius r dash. So, r dash we want a relation, and then perpendicular distance from S to the line joining I and O. So, from S to the line joining IO I want perpendicular distance. Okay. So, first to begin with, so see what we know here is what they are saying is they want a relation between r and r dash, right. So, if I want to relate them, so what should we do is see we can do like this. First we have a circle touching a side, and there is another circle touching this externally. Okay. So, this is I, this is O. So, IO is equal to r plus r dash, because these circles are touching each other externally, and then there is a circumcircle and there is an incircle. I mean there is a circle which is touching it internally. So, this circle center is S, this circle center is O. So, SO is equal to capital R minus R dash, because these circles are touching internally. If they are touching internally, distance between the centers is nothing but difference of the radii of the two circles. So, R minus R dash, this is R plus R dash. So, and then so, if I want the distance IF, I want IF is small r, and then so let us say now we will draw a line IO, I and this line is O. So, from S we want perpendicular distance also. Okay. So, let us say I will call this point as E, because it is not given, right, E. So, if I draw a perpendicular onto the baseline, I mean base BC, if I draw a perpendicular from S to BC, and this is anyway perpendicular because IF is nothing but the normal line to the circle. So, this is perpendicular. So, SE is mathematically equal to, so let us say if I call this MN, so SE is mathematically equal to MN. So, BN we can find, BN is nothing but length of the I mean not N, F, this is F, BF, MF. So, BF is equal to length of tangent from B to in circle, which is S minus B, where S is the semi perimeter, B is the side length. So, S minus B. And then if I want BM, BM is nothing but, so the perpendicular bisector will pass through midpoint of the side. So, BM is equal to half of BC, because that is, what is that? That is passing through the midpoint of the side, because perpendicular bisector definition itself, it will pass through the midpoint. So, this is A by 2. So, I will get SE is equal to MF, which is equal to BF minus BM. So, which is S minus B minus A by 2. What is S? S is nothing but A plus B plus C by 2 minus B minus A by 2. So, which is C minus B by 2. So, the perpendicular distance from S to the line joining IO is C minus B by 2. Okay. So, now we did not get the relation between R, R and R dash, right. So, if I want the relation, already we have these two equations. So, with these two equations, we have to go further. EF length is nothing but, because IO is R plus R dash, right. So, EF length, if I get it, this is R dash anyway. So, IE also I can get it. So, if I want that length, what I can do is, so let us see the triangle ABC, and we have the circumcenter. So, if I join this to the base, if this angle is A, the angle subtended at the circumcenter will be 2A, and from there I am dropping a perpendicular. So, it will be meeting at M. So, if it is meeting at M, if I consider that triangle alone, so this is A, this is A. So, V, M, S, C, this is R. So, if I consider cos A is equal to Sm by R. So, Sm is equal to R cos A. So, Sm length is R cos A, which is equal to EF, yes or no. So, EF is equal to R cos A. And then IF, we know that IF is equal to small r. So, if you see that, you will get IE is equal to IF small r minus R cos A. So, if I use the right triangle here, so if I use the right triangle SEO, O, E, S. So OE length we know. So OE is equal to EF plus OF. So which is EF is R cos A plus OF is R dash. So SE I got it. SE is equal to C minus B by 2, which is 2R cos C, 2R sin C minus sin B by 2. So SE I got it. So SE square plus OE square is equal to SO square, because from the right angle triangle we can write like that. So this is R into sin C minus sin B whole square plus OE is R cos A plus R dash whole square. SO is R minus R dash whole square. So this is a relation between small r and capital R, small r dash and capital R. So from this we can determine R dash in terms of this.